Hello everyone, welcome back to TechOps tutorial. In today's session, we are going to look at very important Kubernetes concept, taints and tolerations. And yes, we will also walk through a demo so you can see how it works in real life. Alright, let's start with very simple question. What exactly are taints and toleration in Kubernetes? Think of taint as a rule applied on a node that says don't place random pods on me unless they are allowed. So when a node is taint, Kubernetes will block pods from scheduling on that node unless the pod has matching tolerations. On the right, we have tolerations. A toleration is basically a permission inside the pod YAML. It tells Kubernetes this pod is okay to run on a taint node. So in simple words, taint equals to node saying pod stay away from me. Tolerations is equals to pod saying it's okay, I am allowed to run here. When both match, the pod can run on that node. If they don't match, Kubernetes won't schedule the pod there. This is how Kubernetes control what goes where, especially for the special workflow, dedicated nodes or a maintenance scenario. Alright, now that we understand what taints and tolerations are, let's look at the three types of taints effects in Kubernetes. The first one is NoSchedule. This simply means don't schedule any new pods on this node unless they tolerate the taint. So Kubernetes will completely block new pods from running here. The second effect is PreferNoSchedule. This one is a bit softer. Kubernetes will try to avoid scheduling pods on this node, but if it has no choice, like if no other nodes is available, then it may still place a pod here. And the third one is NoExecute. This is strictest effect. If a pod does not tolerate this taint, Kubernetes will evict it even if the pod is already running on the node. So this effect impacts a running pod as well. If you look at the diagram on the right, you can clearly see how each taint effects behave. With NoSchedule, pods are blocked. With PreferNoSchedule, Kubernetes still avoid that node but will use it if needed. And with NoExecute, existing pods are removed because they don't tolerate the taint. And the one key point to remember, only NoExecute can remove pods that are already running. The other two only affect the new scheduling. Before we move to the demo, let me quickly show you a few common mistakes people make when working with taints and tolerations. These happens very often, especially when you are new to Kubernetes. The first one is missing toleration. Sometimes we create a pod but forget to add a toleration section in the YAML file. If the node is taint, Kubernetes simply won't schedule the pod and you will keep wondering why it's stuck in pending. The second common mistake is using the wrong key, value or effects. Your taint might be key 1 equals to value 1 colon no schedule, but in the pod you may write a different key or a different effects. If they don't match exactly, Kubernetes will not allow the pod to run on that node. And the last one is node name typo. This happens more often than you think. When applying taints, if you type the wrong node name, even an extra character, the taint won't be applied. So always double check the node name before running the command. These are small mistakes, but they can waste a lot of time during troubleshooting. So keep an eye on them. Alright, let's walk through what we are going to do in this demo. First, we will start by tainting a node. I will add a key value pair so the node becomes restricted. Basically, we are telling Kubernetes, hey, only pods with the right tolerations can run here. Next, I will try to schedule a pod without any tolerations. This pod should fail to run and you will see it's stuck in pending. That's expected. and it helps us to understand how taints block workloads. Then we will fix that. I will open the YAML file and add a toleration so the pod is allowed on that tenant node. After that, we will reschedule the pod, and this time it should run fine on the same node that blocked it earlier. And finally, we will apply a NoExecute effect. This forces Kubernetes to evict the pod. So that's the full workflow. Taint the node, watch the failure, add toleration, reschedule the pod, and then test eviction. Simple and hands-on. Let me access the terminal. Now let's see taints and toleration in action on Minikube. We will taint a node, try scheduling a pod without a toleration, then fix it with a toleration. You will see the NoExecute effect in action. Alright, before we start working with taints and toleration, let's quickly check our Minikube node and status and all the running pods. You can see here I have a single node called Minikube and its status is ready, which means the cluster is healthy. So everything is in good state. Now we can start the demo. I have only one Minikube node. If you had taint a wrong node, the demo will not work. So here by default it will work because we have only one node and we are applying taint to this node only, Minikube node. Now let's apply our first taint to a Minikube node. I'm adding a taint with the key 1 equals to value 1 and the effect is NoSchedule. This means Kubernetes will not schedule any new pods on this node unless they have a matching toleration. kubectl taint nodes. I am giving the Minikube node name, provide key 1 value 1 no schedule. Okay, I have already run this command. So node Minikube already has key 1 taints with the same effects. Overwrite is false, means we can check or we can describe it by using kubectl describe node Minikube grep-i taints-e2. The same value it has. So let me show you how you will get the output if it is not applied earlier. We can run kubectl taint nodes Minikube key 1 no schedule. I forgot to mention hyphen. So I have removed the taint. So let's start with the demo. I will reapply the taint and we'll continue the demo. Now I am applying the first taint to the Minikube. kubectl taint nodes Minikube key 1 equals to value 1 no schedule. You can see the terminal shows the node/Minikube taint, which means the taint was applied successful. We can also describe node Minikube grep-i taints. This is the expected output. When I run the describe command and filter for taints, you can clearly see it here. Key 1 equals to value 1 no schedule. So the taint is active on the node now. Just to make sure you taint the correct node name, if you taint a wrong or non-existing node, the pod may still schedule normally and the demo won't work. So we will schedule a pod without toleration. I have already created a YAML file. This is a small YAML file. Now I am going to create a pod that does not have any toleration. Since our Minikube node is 10, Kubernetes should block this pod from being scheduled. Let's apply it. Pod is created. It is in pending state. Now let's describe the pod. kubectl describe pod followed by the pod name. Here you can see 0/1 nodes are available. One node had untolerated taints. As you can see, the pod is stuck in pending state. This is expected because the node has taint and this pod does not tolerate it. If you look at the event section, Kubernetes clearly says 0/1 nodes are available. One node had untolerated taints. So this confirms that the taint is successfully blocking the pod from scheduling. Sometimes people forget to apply the taint or they taint a wrong node. If the pod accidentally schedules and start running, that means your taint was not applied correctly. Let's schedule a pod with toleration. Pod with, I have already created the YAML file. This is the YAML file. Now we will create a pod that has a toleration matching the taint we applied earlier. Since the pod's toleration matches key 1 equals to value 1, NoSchedule, Kubernetes should schedule it successfully on the tenant node. Let's apply it. kubectl get pods. The container is creating. It is taking time. As you can see, the pod is running now. It is in running state. This we have created pod with toleration. Let's describe it. kubectl describe pod followed by pod name. Looking at event from kubectl describe, Kubernetes pulled the Nginx image and created the container and started it successfully. This clearly shows toleration allow pod to run at tenant nodes. As you can see this output, kubectl get pods. Pod with toleration is now running and it's scheduled on Minikube nodes. The old pod without a toleration is still pending. Double check the key value and effects in your toleration. Any mismatch will keep the pod in pending state just like the first one. So let's demonstrate NoExecute effect. kubectl taint nodes Minikube key 2 equals to value 2. We will give NoExecute. kubectl describe node Minikube. You grep -i taints -a2. We are going to demonstrate the NoExecute effect. Any pod without a matching toleration will be evicted from the node. This is particularly useful for node maintenance or safely draining nodes. Here, using kubectl describe node Minikube pipe grep -i taints -a2, you can see the both taints applied to the node now. Key 1 and key 2. kubectl get pods. Here you can see this pod has been evicted. You may notice pod without the matching toleration are still pending or running depending on the previous step. Pod without the correct toleration for key 2 equals to value 2 will be evicted after a few seconds. This shows how Kubernetes enforces the NoExecute effect. Pod with why this has been evicted? Only one pod is there which is in pending state, and the running pod has been evicted because of here we don't have key to value pair. This it requires key 2 equals to value 2 NoExecute. So let's see how we can execute a pod with NoExecute toleration. I have created the YAML NoExecute toleration.yaml. Here you can see I have added a key 2 equals to value 2. Here we have missed to add key 1. Let me add that. We included both. Let me add this. We included both tolerations so the pod can schedule on the node and survive the NoExecute taint. Let's apply the pod. kubectl -f kubectl get pods. As you can see, NoExecute toleration pod is running 4 seconds ago. Here we have created a pod that tolerates both NoSchedule and NoExecute taint. As you can see, it is running on a Minikube node. It survives the NoExecute taint. Any pod without a proper toleration would have been evicted. This clearly demonstrates how toleration controls which pods stay on a node during the maintenance. And here common mistake might be forgetting to include a both toleration, pods stay pending or get evicted. You may expect instant eviction. Kubernetes may take a few seconds to evict a pod if you skip adding the two key values. Typo in key, value or effects field. These are all the common mistakes you may face if your demo is not working. Now let's clean up the demo resource. kubectl delete pod. And the command to remove the taints, kubectl taint nodes. Command will be same, just key 1, remove the value and mention NoSchedule with hyphen. Minikube untaint. This we have done for key 1. We need to do it for key 2 as well. Here we have given NoSchedule. Actually it's NoExecute. Finally, we clean up all the demo resource. We deleted the pod that were created for the demo. We remove the taints from the Minikube node so it returns to a normal state for further use. So we can also do a verification like kubectl describe node Minikube pipegrep -i taints -e2. Here you can see the taints is none. Let's move to the slide. Alright, before we wrap up, let's quickly recap what we learned in this session. First, we saw how taints push pod away and how toleration let certain pod run on those taint nodes. So taints act like a blocker and toleration acts like an exception. Next, we talked about the three taint effects you will run into: NoSchedule, PreferNoSchedule, and NoExecute. Each one control how the schedulers or the node reacts to the pod. And finally, we reminded ourselves to always validate the YAML, the keys, the values, and the effects. A small typo in YAML can break your whole setup, so it's always worth double checking. If you found this video helpful, don't forget to like, share, and subscribe to TechOps Tutorial for more Kubernetes and DevOps tutorials. Thanks for watching, and I will see you in the next one.